Hello students, this is the 14th and the last video that I prepared in this series to explain how to use this Casio graphic display calculator. Okay, so let us continue. Let's do the 49th problem. Reaction times of human beings are normally distributed with a mean of 0.76 seconds and a standard deviation of 0.06 seconds. The graph below is that of the standard normal curve. The shaded area represents the probability that the reaction time of a person chosen at random is between 0.70 and 0.79. Write down the value of A and of B. Now, is given very clearly this standard, this word is in bold font, isn't it? So that is very important. It's a standard normal curve. Now, A and B. So you may think that A is 0.70 and B is 0.79, which is incorrect. Okay. So A is nothing but the Z equivalent of 0.70. We know that for standard normal variable, we use the uh, letter Z. Okay. For just a normal variable, we use X. So let us say if this is X, X1, then this A is the Z equivalent of X1. So how do I find that? We know that Z equal to X minus mu by sigma, right? So that means A equal to 0.70 minus 0.76 by 0.06. So let us see it here. Yeah, you'll get the answer as minus 1. Okay, so if you 0.70 minus 0.76 is 0.06 and that divided by 0.06 is minus 1. So the value of A is minus 1. Same way, B is the equivalent of Z equivalent of 0.79. That means to find B, you subtract 0.76 from 0.79 and then divide it by 0.06. So you'll get the value of B. Okay. Calculate the probability that the reaction time of a person chosen at random is greater than 0.70 seconds. So P of X more than 0.70. Okay. So statistics, distribution, normal. Now I need to find the probability here. So NCD. Here I need to find P of X more than 0.7. So that means the lower limit is 0.7 and upper limit will be, let's say, 10,000, and sigma is 0.06 and mu is 0.76. So the answer is 0.841. The probability is 0.841. So yeah, 0.841. Find the probability that the reaction time of a person chosen at random is between 0.70 and 0.79. So again, it's quite simple. So here the upper limit will be 0.79, lower limit will be 0.7, upper limit will be 0.79. So 0.79 and everything else remains the same. So the probability is 0.5328, so 0.533. That's right. Okay. Then we'll solve the next problem. It is claimed that the masses of a population of lions are normally distributed with a mean mass of 310 kilograms and a standard deviation of 30 kilograms. Calculate the probability that a lion selected at random will have a mass of 350 kilograms or more. So I need to find the probability here, P of X more than 350. So that means the lower limit is 350. So I'll go to lower limit is 350 and upper limit is 10,000. And sigma here is 30 and mean is 310. Okay, the probability is 0.091. So let's check. 0.091. Sorry, just a minute. 0.0192. I'm sorry. So three significant figures, right? So 0.0912 because this 0 doesn't count. It is not a significant figure. Okay. The next part. The probability that the mass of a lion lies between A and B is 0.95, where A and B are symmetric about the mean. So find the value of A and B. Okay, so it means that let me use here. Let's say this is this is the mean, then A and B will be equidistant from the mean. Okay, that means let's put it this way. I showed you here. So this is A and B. They are equidistant from the mean. So how do I find the answer? How do I find the value of A and of B? Very simple. Exit. I know the area now. I need to find the what is that? The mass of lion. So A and B. So let us say the area is 0.95. So exit, distribution normal, inverse normal. Now here I'll put tail as the center. Okay, because I know since A and B are equidistant from the mean, symmetric about the mean, so tail will be central, and then area will be 0.95, and sigma and mu remains the same. So here you get 251.251. A is 251 and B is 369. Let's check. Yeah, 251 and 369. Okay. So let us solve the this is the final problem of this worksheet. The mass of packets of a breakfast cereal is normally distributed with a mean of 750 grams and standard deviation of 25 grams. Find the probability that a packet chosen at random has mass less than 740 grams. So, straightforward question. Exit, distribution, normal. I'll use NCD. I need less than 740. So, the lower limit will be minus 10,000. Upper limit will be 740. Sigma is 25, is it? Yeah, sigma is 25. Mean is 750. So the probability is 0.345. So A1, 0.345. Find the probability that the packet chosen at random has mass at least 780 grams. So which means P of X more than or equal to, greater than or equal to 780. So which means the lower limit will be 780 and the upper limit will be 10,000. Everything else remains the same. So the probability is 0.115. So for this one, the answer is 0.115, the probability. Yeah, that is correct. And third subdivision, between 740 and 780. Okay, so the lower limit will be 740. And there is, of course, there is another way which I'm going to tell you, and the upper limit is 780. So answer is 0.540. So 0.540. And as I said, there is another method here. We already know less than 740 and more than 780, right? So you can add these two answers and subtract it from one. You will get the answer for the third one. That is another method. Two packets are chosen at random. What is the probability that both packets have a mass which is less than 740 grams? Okay, so we found the answer for this, isn't it? This is a probability that a packet chosen at random has mass less than 740, and the answer was 0.345. Correct. Now two packets are chosen at random. What is the probability that both of them have a mass which is less than 740? That means the first one should have mass less than 740 grams, and that's very, very important. And the second one should also have a mass which is less than 740 grams. So the answer is 0.345 multiplied with 0.345. So the answer is 0.345 squared. So here 0.345 squared. And the last part, last question. The mass of 70% of the packets is more than X grams. That means P of capital X more than small x is equal to 0.7. Find the value of X. Okay. So when you say P of capital X more than small x. So let me type it here for you. So here p of capital X greater than small x equal to 0.70. Okay, so this is what you get. This is the expression, the equation that you write. Uh, then find the value of x. Okay, so here I have the area, so I need to find the have the probability. I need to find the value of x. So I'll use inverse normal. So sorry, let's see this here. So exit distribution, normal, inverse normal. Now here tail will be on the right hand side. So tail is right, area is 0.7, and sigma and mu remain the same. So the value of x is 736.8, so 737. So let us check. Yeah, the answer is 737 grams, right? Okay, fine. So that's it, students. I hope these videos were useful to you to understand how to use this calculator, and also how to solve the IB Math SL questions using this calculator. Okay, so if you have any feedback, you can of course mail me. You know my email ID. You can mail me. And thanks for watching all these videos, students.